In this video, you will learn how to calculate electric field for a given electric potential. And we have another problem in that electric field is given and we have to calculate the electric potential. So let's learn these two problems in this video. Electric potential at any point is given as V equals minus 5x plus 3y plus square root of 15z. Now we have to calculate the magnitude of the electric field. So we know this formula, electric field equals minus dou V divided by dou R. This is a delta V by delta R, you can say. And this negative sign indicates that the direction of the electric field is in the decreasing potential. Suppose we have equipotential surfaces like this, and if the direction of the electric field is this way, definitely the potential is decreasing. For example, if this is the potential VA, VB and then VC of these three potential surfaces, then definitely VA is greater than VB is greater than VC. So the electric field direction is in the decreasing potential. That's the negative sign. Now we have to remember another thing. This is a scalar quantity and this is actually a vector quantity. So in terms of vector quantity, we can write this same equation as minus dou V divided by dou X I cap minus dou V divided by dou Y J cap minus dou V divided by dou Z K cap. It means that if we differentiate this potential given, and we can calculate the electric field. So let's do that. So in the potential, there are three terms. Only the first term has x. So if you differentiate v with respect to x, you will get only minus of minus 5 and I cap. Then dou v by dou y. If you differentiate the electric potential with respect to y, only the second term has y in it. So you will have minus 3 j cap. Then do the same for differentiating electric potential with respect to z. The third term only has z in it. So if you differentiate that, you will have minus square root of 15 and k cap. That's it. We have got the electric field vector now. So let's rewrite this with proper signs. 5i cap minus 3j cap minus square root of 15 k cap. So this is the electric field vector. But it is asked in the question the magnitude of the electric field we have to find. So for any for any vector, we can calculate the magnitude as the square root of the x component squared plus y component squared plus the z component squared. So this gives you 25 plus 9 plus 15. This will be 25 plus 9. So this will be square root of 49. So this gives you 7. So 7 is the answer. So that is the magnitude of the electric field. So it should be with the unit Newton per coulomb. So we learned the technique how to calculate electric field for the given potential. Now in this problem, electric field is given at a point and the electric field produced by a point charge is given at a point, and we have to see the question like we have to find out the energy of the charge when it reaches the position x equals 2d. So here the electric field is given and it accelerates another point charge along the x-axis. Okay, and we have to find out the energy of the charge at x is equal to 2d. So there's a point charge q and the electric field varies along x-axis, and the its function is given. Function as a function, electric field as a function of x is given, and we have to find from x is equal to 0 to x is equal to 2d at this point p, the electric no the energy of the charge we have to find out. What will be the energy of the charge? It's like the work done by the electric force. Here it's the electric force of repulsion, maybe electric force of repulsion. So work done by the electric force is q times v, we know it. So we have to calculate first what is v. Then we have to substitute in this equation to get the work done. So how to do that? Now we know E relation, just now we learned it is minus dou V by dou R. Minus represents the electric field direction, so we can just leave it for the moment. So here we can write this as dou V equals E dou R. And if we want the electric potential, we can integrate this electric field times dou R. That's it. So let's substitute that electric field here. Equation here, E is E naught 2x by d plus 3x squared divided by d squared, and here everything is a function of x, so we can integrate with respect to x. So that is v. So let's do this integration. Here E0 is actually a constant, and this integration is actually from x is equal to 0 to x is equal to 2d. So we can integrate the first term first. First term 2 divided by d, integration of 0 to 2d x dx, plus 3 divided by d squared, integration of 0 to 2d x squared dx. Now if we do this, here E0, we have 2d. If you do this integration, we'll get x squared divided by 2, because the formula is x power n plus 1 divided by n plus 1. Here n is 1. So the limits are 0 to 2 by 2d plus 3 divided by d squared, integration here x cube divided by cube, because the n is equal to 2 here, so x power n plus 1 is 2 plus 1 3 divided by 3. Limits go from 0 to 2d. So here if you write E0, substituting the upper limits, lower limits we are not going to substitute because it is 0. So we can write this as 2d squared, so 2 d squared divided by 2 plus 3 divided by d squared, here 2d cube divided by 3. Let's simplify this. So we have E0, 1, 2 and 2 will go away. And here 1d will go away, so we have 2 squared is actually 4, and 1d will go away. We have 1d plus 3 will go away. D squared will go away, so we have a 4 d. That's it. no, here 2a8, so this should be 2 cube is actually 8, so we'll have E012D. Now we have got the potential, and now what we have to do, we have to calculate the work done. Since it is asked what is the work done or the energy of the point charge, Q times V. So we have to multiply this like a 12 Q A0D. That should be the answer. So let's check the options. Here it should be, yes, 12 QDE0. So this is the answer. Thank you so much.